All right, all right. Let's begin tonight's class already. So as you can see here from the syllabus, what is the goal? The aim of the Unified Tertiary Matriculation Examination 2026 syllabus in chemistry is to prepare the candidates for the board examination. It is designed to test the achievement of the course objective, which are to understand the basic principles and concepts in chemistry, interpret scientific data relating to chemistry, deduce the relationship between chemistry and sciences, and all of those things you are seeing there. Apply the knowledge of chemistry to industry and everyday life. So, like I told you, our focus is aligning whatever it is we are teaching with the syllabus. So the topic we are going to be looking at right now, in the next 5 minutes, I'm just going to get on to the topic, and then we do a CBT drill of 10 questions, like the same way we did for English. Just follow along, put whatever answer you think is the answer, and then at the end of the day, let's see what you got. I mean, let's see your ratings, and you also know where you stand. So we are looking at separation of mixtures and purification of chemical substances. So what we are looking under it, we are looking at pure and impure substances, boiling and melting points, elements, compounds and mixtures, chemical and physical changes, separation processes. And we are going to get into all of that in the next 5 minutes. So get your writing materials to pen down the significant points. So I may not be able to type them, so but I will repeat it as many times as possible for you to be able to grab it and note it down. Okay, so let's begin. So as you have it here, what is um, JAMB expecting you to understand on the separation of mixtures and purification of chemical substances? So the first objective there is that you should be able to distinguish between pure and impure substances. So what are pure substances and what are impure substances? The easiest way for you to identify it is to do what we call the test of purity. So if you want to test for pure substances, there are three things that are necessary for you to put into place: the boiling point, the melting point, and then a pure substance. We always give a single spot on a chromatogram paper. So what does impurity do to the melting point and what does it do to the boiling point? Now, impurity always increases the boiling point. For instance, the boiling point of water is 100 degrees Celsius. So impurity will increase it. So if in a case you have the boiling point of water to be like, let's say 120, you know that impurity is present. And then impurity also lowers the melting point. So what's the melting point of water? Again, that's 0 degrees Celsius. So if it is lower than 0 degrees Celsius, then you know that an impurity is present. So the presence of an impurity lowers the melting point and increases the boiling point. And then a pure substance, you also give a single spot on a chromatogram paper. And we are still going to get into what a chromatogram paper is and what chromatography is much later. So now the next thing is you should be able to use boiling and melting point as criteria for purity of chemical substance. I've already talked about that. Now let's move on to the next point there, which is distinguish between elements, compounds, and mixture. So let me make the voice note short so that it will be easier for you to get it and note it down and go to the next. Okay, so now let's distinguish between elements, compounds, and mixture. So what are elements? The simple and direct answer to that is that element is a substance which cannot be splitted by an ordinary chemical process. So they exist as a separate entity and they cannot be splitted by an ordinary chemical process. That's element. And you have about close to 109, or I think it's about 117 discovered elements now. At least at this level, you should be able to know the first 30 elements. My students know it up to 50. I make it a compulsory thing for them to memorize the first 50 elements, and they do know it. So that's from hydrogen to tin, which is the 50th element. But if you are just starting, at least you should be able to know the first 30 elements, that hydrogen to zinc, which is the 30th element. So what is a compound? A compound is the mixture of two elements that are chemically combined. That's a compound. So you say sodium chloride, that's NaCl, is a compound. The common name is common salt. And then you also have water, which is H2O, that is also a compound. One amazing thing about a compound is that it has a chemical formula, but mixture does not have a chemical formula. So when you're talking about a mixture is the joining of two or more constituents physically. So air, that's AIR, is an example of a mixture. Blood is a mixture. Soil is a mixture. And then you also have milk is a mixture. Urine is a mixture. Urea is not a mixture. Urea is a compound. So what are the easy differences between a mixture and a compound? A mixture, first of all, is physically combined. A compound is chemically combined. A mixture does not have a chemical formula, but for instance, what is the chemical formula of air? That's AIR. No, there is no formula for air. There is no formula for blood. What's the formula of water? Water is H2O, so it has a chemical formula. So a compound has a chemical formula. And then another thing again is that a compound, gives birth to a new substance entirely different from the constituent. So which means the constituent of compound is of water, for instance, is hydrogen and oxygen. Hydrogen is a gas, oxygen is a gas, but by the time the two of them combine together, they form a different compound entirely, which is water. Nitrogen burns with a pop sound, while oxygen burns, rekindles a glowing splint, but water itself does not support combustion. It, as a matter of fact, kills fire. So you see that it gives birth to something entirely different. A compound gives birth to something that is entirely different from its constituents. So that's a chemical change right there. And we are still going to get into a chemical change shortly. And then a mixture, on the other hand, it is a physical change. It can be separated physically. So the components that you find inside a mixture still retains their individual property. So for instance, inside air, for instance, you have oxygen, you have nitrogen, and the oxygen that is present in the air still has its property. The nitrogen that is present in the air still has its property. The carbon dioxide that is present in the air still has its property. So let's move on to the next point. Then the solution of salt in water is not a chemical change. That's a physical change. That's if you dissolve salt in water, you can still get the salt back through some certain separation techniques. So that takes us into physical change. Physical change, they are physically, joint, physical change, no new substances are formed, and then it is also easily reversible. Compound, but you can separate a mixture. So there are some basic ways you can use in separating a mixture. Number one, you have filtration, you have decantation. So filtration and decantation are used to separate insoluble particles from its solution. So if you go to fetch water in a river, you know that if that water is a little dirty, after a while, you take that, you fetch it, you put it in the bucket. After a while, what happens? And if the water is left to stand, you see two layers. You see the upper clear layer up, and then you see the lower muddy side underneath. And what has happened there? The sand particles that have come together or coagulated together at the bottom are insoluble, and you can easily pour it quickly, easily. You can just pour it carefully into another bucket. Many of you have done that many times. You pour it carefully into another bucket. That is what? Decantation. What a much more professional approach to it is when you now use a filter funnel and use a filter paper, and then you pour it so such that the dirt stays on the filter paper, and the one that is the water, the clear water, flows easily. That is what filtration. So you use filtration and decantation for separating insoluble particles from their solution. And then you have the next one, which is what you can use in separating soluble solute from their solution. So there are some particles that are actually soluble. Like for instance, the common salt, that sodium chloride that you use at home, is very, very soluble in water. So when many times you have dissolved it in water, you realize that the salt mixes with the water. So it forms what we call an homogeneous, what's it called? It's homogeneous, rather, it's single, it is one, it has that oneness. So what do we use in separating such kind of solution? You use evaporation, you use crystallization. So you only use evaporation when the particular particle you want to separate cannot be decomposed by heating, because evaporation involves heating. You have to heat that particular mixture in such a way that all the moisture are evaporated, that is, they dissipate into the air. Evaporation means liquid turning to gas. So, and then at the end of the day, you have only the salt particles left, or the particular particle you want to separate left. But when you are dealing with a situation whereby the particular salt particle, or let me say the solute particles that you want to separate, can be decomposed easily by heat, you use crystallization method. So evaporation is much more used in sugar industry, in the salt making industry. That's evaporation. And you use what's it called now? Crystallization in the sugar industry, because sugar can easily be decomposed by eating. And when I say solute, solute simply means a particular thing that dissolves in water. So solute, solvent, solute plus solvent. Solvent is the water, solute is the salt, for instance, if it is common salt. So the mixture of the two of them together forms what we call a solution. So having talked about how to separate a soluble solution, a soluble solute from its solution, then the next thing now is to talk about how you separate miscible liquids. So when you are talking about miscible liquids, these are liquids that can mix together. So for instance, you have ethanol. Ethanol is palm wine and water. They can mix. So when you want to separate that, you use what we call distillation method. And we also have what we call fractional distillation. We use fractional distillation to separate miscible liquids also, but that have closely near boiling point. So their boiling points are very near. So for instance, crude oil contains petrol, contains kerosene, diesel, it contains natural gas, bitumen, and all of that. But you use fractional distillation to separate them because the boiling points are closer. They are not far apart. Even in the production of distilled water, you use distillation method in the production of distilled water. Distilled water is actually the laboratory or the artificially made pure water. Now, that's not the pure water you are buying outside that they put inside sachet. That one is sachet water. Real pure water that is pure, chemically pure, is distilled water. And that one is made in laboratory. While the one that is naturally occurring, you have rainwater, you have water that you have from springs. Those are examples of pure, naturally occurring water. So now, moving on. Okay, so moving on. When is it said for us to use and the next separation method, sublimation? We also have sublimation. Sublimation is when you want to separate solutes that can sublime. So when you say something can sublime, it means it moves from solid to gas. So when something moves from solid to gas, you say it has undergone sublimation. And then you also have magnetization, magnetic separator, sorry. So when you want to separate mixtures that are magnetic, that are attracted to magnet, like iron filings. So if you have a mixture of sulfur and iron filings, you can easily use magnetic separator because the iron filings will be attracted to the magnet, while the sulfur, of course, will not be attracted to the magnet because sulfur is not ferromagnetic. Iron is ferromagnetic. That is why it can be attracted to magnet. Then you have chromatography. So chromatography is actually used to separate colored solutions. So for instance, the production of ink, you use chromatography in the process to separate all the different colors, all the different layers of colors, the blue, the black, the red, and all of that. So use chromatography to separate colored solutions. So which one again am I still missing there? Then you have some of the other parts that we have the precipitation method, we have the fractional crystallization. So let me talk about fractional crystallization. Fractional crystallization is used to separate a mixture of different soluble salts. So let's say if you have a mixture of sodium chloride, which is soluble, calcium chloride, which is soluble, and then you also have, which other salt is soluble again? You have potassium chloride, which is soluble. We have them, all of them mixed together, and you want to separate them because all of them are soluble. Everything forms an homogeneous mixture. That's a single form. You can't get to know the one that is potassium chloride or the one that is calcium chloride or the one that is sodium chloride. So what do? You use fractional crystallization. Now, what does fractional crystallization mean? It uses their different solubility point. Now, solubility has to do with the fact that the many salt solutions, or let me say substances, they have different temperature at which they are soluble. So there are some, like maybe sodium chloride, that are soluble at room temperature, that is at 25 degrees Celsius. Something like maybe calcium chloride may be soluble when it is only at 50 degrees Celsius. And then you may have, let's say, potassium chloride that may be soluble at, let's say, 15 degrees Celsius. So you take note of their solubility point, and their solubility point is what you are now going to use in separating them based on their temperature. So the one that is at 15 degrees Celsius, the one that is soluble at 15 degrees Celsius will retain its solubility as long as the temperature is at 15 degrees Celsius. But the moment it is beyond that particular temperature, it doesn't, it filters out from the solution. So you take note of their solubility point, that's the solubility temperature, to know when you will separate these three different substances. I hope I did not confuse you from that explanation. And then, yes, you have immiscible liquids. There are some liquids that do not mix. So when you are dealing with immiscible liquids, liquids that do not mix, you use what we call separating funnel. Separating funnel. So you use separating funnel to separate liquids that do not mix together. So you use separating funnel for that. And then examples of that are oil and water. So you know that oil and water cannot mix together. So you use a separating funnel for that. All right. So that's all for now. So let's get into some drilling. So I plan to make it 10 questions before, but we are already far, far beyond schedule. So I'm just going to make it 5 questions, 5 selected questions that aligns with what we have talked about. And then I'm going to be explaining the process of the answer as we go along. So just rate yourself from that end. For this particular one, number one, says a small quantity of solid ammonium chloride was heated gently in a test tube. The solid gradually disappears to produce two gases. So later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone, the answer there is sublimation, option B. I told you already that sublimation is when something moves from solid to gas. So that's the answer. Okay, so for number 2, by means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride, and the probable answer is sand, B, because the rest of the options there, they are also soluble in water. So the only one that can be obtained pure by means of filtration. Filtration means that there is something there that is insoluble, and the only insoluble substance here is actually sand. So B is the answer. For number 3 question, a mixture of sugar and sulfur can be separated by, you first of all add water to the mixture. So by adding water to the mixture, it separates them into 2 layers. So you have the sugar, of course, because it's soluble, will be at the top, at the upper layer, and then you have the sand, the sulfur will be at the bottom layer as a residue. So the probable option here is C. So the solution in water, then followed by filtration, you filter out the sulfur that is insoluble, and then gentle eating, that's evaporation, not serious eating. You know, sugar can easily be decomposed by heat, by strong eating. So, but if it is a light eating, it can still sustain the sugar. But in practice, crystallization method is better in extracting a pure sample of sugar. For this number 3, option C is the answer. Okay, for number 4, which of the following is a physical change? Freezing ice cream is a physical change. Dissolving calcium in water is chemical. Burning kerosene is chemical. Exposing white phosphorus to air is chemical. So the answer here is A. Then the next one, which of the following is an example of a mixture? So common salt, that's sodium chloride. That's a compound. That's not a mixture. Blood is a mixture. Sand is a compound. Washing soda, that is sodium triisocarbonate 4. That is a compound. So the only answer here is option B, which is blood. Okay, next question. Which of the following substances is a mixture? So sulfur powder is a compound. Bronze, that's a mixture. That's an alloy. That's an alloy of copper. It contains copper and tin. So that's a mixture. Distilled water is not a mixture. It's a compound. It's H2O. And then you have ethanol. Ethanol is also a compound. That's an organic compound. So the answer here is option B, bronze. Then for the number 7, which is the final question, which of the following is not a mixture? So the answer here is you have A, air. Air is a mixture. I told you earlier. Mercury. Mercury is an element. It's actually an element, the only metal that is in liquid state. So element, milk is a mixture. Cement is a mixture. It's a compound actually, though it's a mixture of water and calcium carbonate. So it goes for a mixture, not a compound. So the answer there is mercury. Mercury is an element. It has a symbol of Hg.